Well, thanks a lot for coming. This is a very optimistic talk. Quite tricky to write, it turns out. It's quite tricky to push your testing upstream. You may or may not know my name from talking about GNOME and openQA testing. This isn't the same talk again, talking about GNOME and openQA testing, even though I am going to relate it to GNOME because that's what I'm involved in. And I'm going to relate it to openQA because that's pretty much the best tool we have. But it's more about kind of a vision of the future than what we have today. Firstly, we've come a long way, right, in the desktop Linux world. In the early 2000s and the late 90s, you'd install a Linux distribution and you'd go, okay, like the graphical desktop doesn't work, let me fix my Xconfig. And then, maybe it'd be nice to have Wi-Fi. I wonder why that doesn't work. And then, if you were lucky, you'd have audio as well. So today, things are a lot better. I mean, there used to be a distro as well where you couldn't do dist upgrades. They'd say, delete your old installation and install a new one. It'll work better. And we've come a long way. Now we have much better testing. We test things like upgrades, and I like to use this example as one of the things that's really horrible to test, right? If you open an MP4 file in Fedora and you try to play it, it doesn't work because you don't have the right codec. So this dialog box looks very simple. It just pops up and says, oh, you need a codec. But the code underlying this to make it work is hugely complex. You have a GStreamer plugin, you have something in the video player to handle messages from the plugin, and you have GNOME software, which is incredibly complex in itself. Testing that is quite tricky, right? Because you need all of these bits integrated together. So I'm a big fan of end-to-end testing of the kind that openQA does, where you test the entire system. You test the entire operating system either on hardware or on a virtual machine. So you have you control the kernel, you control the user space, and everything. And another key part of this type of testing is that you navigate the system like an end user would. So you don't connect to the serial console and type serial commands. That's not how most people interact with a desktop machine. You inject keyboard events and mouse events, because real users use a keyboard and a mouse. And we navigate a UI by looking at what's on the screen, right? So if you want to test the OS like a real user, if they're trying to find the cancel button, they look for a shape that looks like a button and says cancel on it. Doesn't matter if it's here or if it's here, really. Just they're looking for that. And openQA has really good support for looking for something that looks like a button and says cancel. And if the GNOME developers decide in the next release it needs to be up here instead or on the right, the test might still pass because the user could still find the button. So who's doing this kind of testing today? I'm going to open the floor to questions. Shout out the names of some distros that are doing this. Fedora, yeah. One of the earliest to adopt openQA. OpenSUSE, definitely, the original. Anyone else? Alma Linux, yeah. Anyone else? Debian, yes. Debian actually has quite a well-maintained openQA instance, maintained by a couple of volunteers. So I have a list. I think this is a complete list of about 10 openQA instances out in the wild. If I missed anyone, then let me know after. Each one's kind of operating independently from the others, so there's not enough collaboration between these today, which is what I'm going to go into in the talk. But it's very good to see, right? We've come a long way. Well done, everyone. If you work on downstream tests, have you ever had anyone from upstream help you write the tests or help you maintain the tests? Has anyone ever said, oh, in the next version of, we're going to replace gedit with GNOME text editor, so I'll help you update some new tests for GNOME text editor. I think we're still lacking in this area, right? The downstream QA pipelines are still kind of invisible to upstreams, unfortunately. And a lot of people upstream are volunteers, and everyone's overworked, so this is kind of understandable, but can we do anything about it? So what developers want is fast feedback on our changes, right? If you develop an app, it's not much fun to get a bug report a year later. You have a contributor, they send a PR, it has a bug, you merge it, you didn't spot the bug, and a year later you get a bug report. The contributor who sent the PR has probably disappeared and they're doing something else. And you it's all about time, right? What developers upstream want is quick feedback on their changes. And that's how we kind of have this idealized distro model, which at the moment is experiencing some friction as end users want to talk to developers directly, and developers want to ship binaries to end users directly, and the sort of traditional model that we've had for 30 years has some friction. So, being involved in GNOME, I put some thought into how we could move testing upstream. And the first thing we did was a few years ago now, back in 2021, and we set up an openQA instance, which is difficult for a few reasons. Firstly, GNOME is, and has always been, independent from any distro. So we have more than 0 paid contributors from at least 4 companies. Did I miss anyone? I always want to make the point that companies should be more loud when they pay people to work on upstream projects, because it's very important that companies do that. But we have more than 0 paid contributors from each of these companies, and most of them are competitors, right? So we don't want necessarily to favor one over the other. It's meant to be a neutral space. If we add end-to-end testing based on Ubuntu, and only Ubuntu, then it's kind of a slap in the face to Red Hat. And the same if we add end-to-end testing based on only Fedora. Also, we don't have much funding for infrastructure in GNOME, and OS images are quite big. So the way we made this work is we don't pick anyone's distro. In the end, we have our own distro called GNOME OS, which is a very simple distro, which is intended at this point just for testing. Everything in GNOME OS is built from master or main, so it has all the latest bugs, breaks regularly, and that's the point, right? It breaks regularly, and then you go, this broke. Why did this break? So, like I say, I've talked about this before, so I won't go into it in too much detail, but it's working. We've got 5 test suites now. It's integrated into the CI for the GNOME build meta repo, which is like the integration repo of GNOME. So when someone releases GNOME 48, that exists as a tag in this repo that then points to all of the modules that make up GNOME 48. So that's where we run the tests. And you can go to openqa.gnome.org and see them. Here's a screenshot of one of the tests that we just test. Does every app start? It's maintained kind of by volunteers, so sometimes it works, sometimes it doesn't. And this is the list of contributors for the Needles repo, the screenshots repo. You can see the first one is me, the second one is Jordan, who's one of the main people volunteering time on GNOME OS. The third person is me again, and the fourth person is Dorothy, who's one of the outreachy interns. So this list isn't long enough. The QA initiative is still fairly invisible within GNOME. And again, module maintainers are mostly volunteers. They're all overworked. So when I chat to them, they say, well, this is great. I really want to do this kind of testing. But I need it to be in my repo. I don't want the test to be in a separate repo and the pipeline breaks after I've merged a PR. I want the testing to happen when somebody opens a merge request in my project. And I want the tests to be maintained as part of my project. Which seems reasonable, right? So can we do it? Well, last year we worked on a prototype. This was part funded by the STF and partly by CodeThink. And we worked on trying to do testing upstream for GNOME Shell. So the reason we chose GNOME Shell is because it's pretty much the most difficult case. I previously did a proof of concept for a Flatpak app, and that's fairly straightforward. But GNOME Shell is the difficult case, right? It has multiple moving parts. It's actually split across multiple repos. It certainly can't be deployed as a Flatpak. So it's hard mode, and if we can get a prototype of that, we can potentially apply it to every module in GNOME that has a graphical component. So again, it's still quite difficult. We still don't have enough infrastructure. And if we try and build a new OS image for every commit to GNOME Shell, then we're going to go crazy, right? So that's 4 gigabytes times however many commits there are to GNOME Shell every day. We also need the tests to be fast if they're going to be in upstream CI pipelines. And if we do it the sort of naive way, then they are not going to be fast, right? Building an image, you can't build a Linux desktop image in less than about 45 minutes. Like, I/O just isn't fast enough. Then you have to download it onto the CI runner. Running the installer takes a while. Booting a machine takes a while. This is, hopefully this will work. I'm going to show you a video of what it looks like to install GNOME OS in a VM. So this is what I tested doing. That's sped up. It actually takes about 3 minutes, but that's what's happening. And at this point, we could actually run a test for GNOME Shell, right? But we've already spent almost an hour getting to that point. With a few tricks, we can make this a bit better. I'd like to go to the next slide, thank you. So with a few tricks, we can make this a bit better. Firstly, we can't make image building fast. So let's, instead of building a fresh image, we already have a stock GNOME OS image, and we just need to overlay whatever's in the pull request. And systemd has a really cool way of doing this called the systemd sysext, which is fairly new. Of course, it's great because it's distro neutral. You only have to adopt systemd, which most of us have. The way a sysext works is it's a little bit like a package, except with none of the things you expect in a package, right? It's a bunch of binary files, doesn't track its dependencies, no use for deploying to end users, but very useful for testing because you get the binary, you overlay it on your rootfs with a overlay fs in one command. Then, let's say we're testing GNOME Shell, so you just restart GNOME Shell, it'll start the new version, and then you can remove it again when you want a shell that works. And you can also drop them into the file system at or during early boot, so you can mount them as disks, use some SMBIOS magic to have them mounted at early boot, and then the system just boots into an OS with whatever change you want overlaid. So this is really good. And it should work for almost anything apart from the kernel. That saves us most of the time. Downloading the images, unfortunately, is an infrastructure problem, which we're not going to be able to solve without more money for infrastructure. So we still have a kind of 10-minute delay there. We don't actually have to run the installer because we can build a pre-installed OS image when we build GNOME OS. So that saves a couple of minutes. And we don't actually have to pre-create a user. To create a user on boot, we can do that via the SMBIOS, or we kind of can. There's still a systemd patch that needs completing before we can do that, but the pieces are there. So we got this kind of working to a prototype standard. This is the first part of building a sysext on every commit. That landed in upstream GNOME Shell. The second part, which is running the tests in GNOME OS, didn't yet land, and there's more work needed before it can land. But we made a proof of concept, and it proved the concept, so I'm quite happy. This is a screenshot of the real upstream GNOME Shell CI pipeline. So this is what GNOME Shell developers are looking at every time they review a merge request. And we can add in a test sysext job, which, let me explain this diagram. I could have done a better job of the diagram, but I was in a hurry. The input to the build sysext job is a container image with the build tools you need to build GNOME Shell. Now, systemd sysexts are binaries, so you have to think about ABI compatibility. You're not going to be able to download the sysext and run it on Debian 9 because it's built using a much more, newer toolchain in GNOME OS. So what we do need to be careful of is that with the container we use to build the binary is the same ABI as the OS we're going to test it against. But that's not a hard problem to solve. So we build a binary sysext. It's available as an artifact on the GitLab CI. And then the test sysext job downloads the sysext, downloads the disk image, overlays the two, and starts an openQA test. And then we can test the app in, if we solve the download problem, a couple of minutes. And the really nice thing about this is that once it works for GNOME OS, it can actually work for any OS. Any systemd-based OS could do the same, right? If you have a container with the build tools, you take a post-market OS container, you build a sysext that will run against post-market OS, and then you boot it against the post-market OS image once the systemd support lands in post-market OS. So it works pretty well. I'm quite happy with the prototype. It's definitely not ready for prime time yet, and for a few reasons. Partly technical reasons, partly infrastructure reasons, and partly stuff that requires a bit more thought, such as I did an openQA workshop at WADEC, the GNOME conference this year, and it was clear that it was the first time that most of the people in that room had even looked at openQA. So there's a lot of work to do, both to make openQA more accessible to people who aren't using it every day, and for people who want to do this kind of testing to learn about what tools we have and how they work. So where do we go from here? This is what I really wanted to talk about today. I hope you're all with me so far. Part of what we need is money to pay people to do work. A lot of this stuff isn't very fun, right? So it'll be great if volunteers can step up and help, but in general it's stuff that's not going to fit into someone's weekend. It's stuff that requires a bit more engineering, and probably we'll have to pay people to do it. The systemd patch maybe is quite easy if anyone's bored and wants to look at a systemd patch. The link is in my slides. But the next problem I want to tackle is having a shared base of how to write these tests. Because if you think about it, you go back when I was looking at all the openQA instances in the world, we have about 10, maybe 10 different openQA test suites, like the SUSE tests, the Fedora tests, the Debian tests, the YAML Linux tests. GNOME has about 200 modules. Not all of them make sense to do graphical testing on, but if 100 of them have openQA tests, we've now multiplied the number of test suites in the world by 10. So what works today, in that we have quite a lot of copy-paste and duplication between the repos, is not going to work when we have 100 such test suites. So we're going to need to work on collaborating a bit more and figuring out what stuff can we abstract. I'll go more into that in a bit. In fact, I'm going to go more into all of this in a bit. I made slides for each of these topics. So on the topic of the shared base, when you look at an openQA test in the abstract, it's quite nice. The DSL is really straightforward and simple. But behind the scenes, there is quite a lot of Perl with quite a lot of history in it. This is the code that I copied from the SUSE tests into the GNOME OS tests to wait for the machine to boot, which it does by checking the serial console to see if a shell prompt has appeared yet. And there's all kinds of... someone obviously spent a long time figuring out that they need to eat failed buffer contents. I don't know. Oh. Technical difficulties. Okay, I hope that still sounds okay. No, that's feeding back a bit. So somebody obviously spent a lot of time and energy trying to... It's got to go lower, okay. Hopefully that'll stay put. So a lot of blood, sweat and tears has gone into this. And ideally we could share that, and everyone who's doing Linux systemd-based testing can share the same code. Now I realize that's difficult because trying to rebase thousands of existing tests on a new base is not going to be straightforward. But at least we can start by saying what should be the shared base that we build on. The current base test class in os-autoinst, which is the test runner in openQA, is completely generic, right? So you could use it to test Windows as much as you could use it to test Linux. But that means you need all this support for testing. You need all this custom code to wait for the boot, and every Linux system has 9 virtual frame buffer consoles, right? So you have to define each of those that you want to use. We could share all that stuff. And hopefully we will. I've been in talks with Santiago Zarate in particular, who works at SUSE, who's quite interested in building this common base. And a spoiler for the end of the talk, we have a monthly call in which we try and work through this stuff, which I'm going to invite you all to at the end, but that's my spoiler. In terms of infrastructure, has everyone heard about the freedesktop.org problem? So freedesktop.org has a fairly major issue, which is one of the infrastructure sponsors, who are generously donating infrastructure, have to stop doing that. And it's going to cause some pretty major disruption, because where do you get a whole load of new infrastructure from with 3 months' notice? This is the reality of doing testing in open source projects, right? It's quite hard to get an ongoing stream of funding and an ongoing stream of paid people who maintain infrastructure. Again, volunteer sysadmins are quite thin on the ground and quite unreliable because they have lives, and people need to be paid to do this work if we're going to have professional quality development. In GNOME, we also have a very small infra team. We're very grateful to Red Hat for sponsoring half of a person to maintain the infrastructure, and the GNOME Foundation pays for the other person. And we have a few hardware sponsors. In fact, most of the infrastructure is currently moving to AWS based on free open source project credits from AWS. So again, that's very nice. But for QA testing, we're going to have more requirements. And we're going to need someone to contribute more hardware so that we can run more tests. Also, my dream would be a hardware test lab so we can actually test, on real laptops and on devices. This is something the GNOME shell team really wants. But again, we need to figure out how to do that and where to host the hardware. With more capacity, we could actually build more stuff as well. So we could conceivably start providing stuff for different distros. Another thing I'm really interested to talk about is making openQA more accessible for newcomers. So the DSL that you write tests in is excellent, right? It's very straightforward. Here's an example. If you want to send a key to the machine under test, how do you do it? So you write send key, and then you put the name of the key, and that's everything. You need to put a semicolon after. It's not too difficult, right? It's really, really straightforward to explain this stuff. You need 4 or 5 commands to do 90% of the testing. But when you look at the real tests today, you realize this isn't quite a DSL, because you can do anything you can do in Perl, and so of course people do anything that you can do in Perl, such as importing 42,000 lines of helper code to do different things that isn't part of the test API. I can see why things have got to this point, but to make things more accessible, we really need to start breaking this up into libraries and sharing and documenting the libraries better. So another fun project. I also personally find that the developer experience for tests is quite hard. I didn't personally like running a web UI on my laptop to write tests. I wrote my own command line tool that connects to ISO to video directly and lets me run tests from the command line. But that's my tool. I think there's more work before it's available and useful to everyone. So, going even further into the future, right? If we get to a point where the tests are written using a real DSL, and they're fully encapsulated, and they don't depend on stuff that's specific to, a lib directory that's only available for the OpenSUSE tests, we can actually share them. So, imagine the dream, right? The GNOME file manager, Nautilus, provides a test suite that says, here are tests for all the core functionality, how to connect a network file system, how to search for a file. Those tests can run in its CI. The same tests can run against GNOME OS. And then downstreams can also use the same tests. Of course, there might be some need to change the needles, right? If you change the theme, then you'll need to update the needles, which is expected, right? And it also gives you a way to test that your theming's working. But this is a distant dream. I don't think we're going to get there this year, but I think we can, if we think about it now, we can set ourselves off on the right path to at least not block our way from getting there. And who knows, maybe in 10 years we will be there. Some of this stuff is fairly simple technical problems, and some of this is what I call the hardest problem in software development, which is getting people to agree on things and talk to each other. So my contribution in this space is organizing a monthly call where it's a vendor-neutral space that people who work on this stuff, upstream and downstream, can meet and talk about end-to-end testing. It's kind of begun with a focus on GNOME and a focus on openQA, but every test tool is welcome and every desktop is welcome. We meet once a month because the world is quite big. There are 24 time zones, so we meet. 1 month it's European morning, Asian evening, and then 1 month it's US morning and European evening. The details are on this GitLab repo, GitHub repo, although I think you have to look in the pull requests at the moment. I'm hoping to merge the pull request that has the info, but you're all welcome to join. The next call is this Thursday at 1600 UTC, and I hope to see you there. And that's the end. Thank you very much. So we have, I think, 5 minutes for questions, or a bit less. Any questions?
Oh, yes.
Thanks for the talk. Just wondering, how are you integrating with the Git forges? I've seen you are kind of tied to the GitLab YAML and this stuff, or how we can, for example, move it to GitHub and other places.
Right, that's something that could be improved in openQA today. The design of openQA initially is that you have static workers maintained by an infrastructure team, right? So you have, SUSE has, I don't know how many dedicated machines that run tests. In GNOME, we don't have that much infrastructure. We don't have any more capacity to spin up, more machines. So we wanted it to run on GitLab runners because we already have GitLab runners. The way we do this is a bit of a hack, right? So each GitLab runner starts a container image. So we use the openQA worker container image as our container image in the GitLab test. That runs a short shell script which first registers with the openQA web UI as a worker. So it says, hi, I'm a worker. Then it submits the job, and the job has a special, I can't remember how we do it, but we have a special parameter so that it goes to that runner, runs the test, sends the results back to the web API, and then destroys itself. So it's a bit of a hack, but it does actually work. Any other questions? Of course, you're all welcome to join the monthly call and ask questions there. Well, I hope I've inspired you to push your testing upstream. Thanks a lot.